Many of the topics we cover in this series may seem obvious or even silly at first blush. Recording data is certainly one of those. Of course, it's important to be careful when you record study data. Recording data that introduces errors could lead to the wrong conclusions. Doing otherwise would be a waste of time. And come on, how hard can it be to record data well? Shockingly hard. But recording data is immensely important to a sound study. It's also the topic of this module in experimental design. One of the first things you need to be careful not to do is record too many things at once. For instance, if you're doing a study of how a drug affects children's activity, you might be tempted to watch them and try and note as many things as possible. You might want to record how much they run around, how many other kids they talk to, how fast they're moving, how much they get up and down. If you try to do that all at once, you might wind up missing something else important. It's likely whatever you focus on first is going to be the thing that gets the most careful attention. It's also likely that what you notice one time might not be what you notice the next. This would be intra-observer variability, which we covered in a previous episode. Or maybe what you notice is different from what a colleague might notice, which would be inter-observer variability, which we've also covered previously. These would result in almost a textbook definition of an unreproducible study because the connection between the potential effects of the intervention and what you recorded is poor. A better method would be to videotape the children and then watch that tape for one piece of data at a time. First note how much they run around, then watch how many other kids they talk to, then look at how fast they're moving, then how much they get up and down. Much more accurate and reproducible. More common sense, but important suggestions. Don't use shorthand or abbreviations. Sure, it might be faster to use V for very active, S for somewhat active, and so on. But later, someone else might think that V stands for very inactive and S stands for slow. You can, of course, keep meticulous records on what codes or abbreviations mean. But each of these steps introduces another chance for things to go wrong. I can't say this enough. Back up your data. Have multiple copies. For electronic data, you might think this is easy, but it's not enough to have a backup hard drive in the room. What if you lose it? It's not enough to have a backup hard drive even in the building. What if there's a fire? You need to have your data backed up multiple times in multiple ways in multiple locations. This goes for non-electronic data as well. If you're collecting surveys on paper, don't think keeping the surveys in a filing cabinet under lock and key is enough. Those data need to be backed up too. This isn't just for safety's sake, although that's important. You may need to go back to the data later. Maybe you'll think of something else you needed to look at in those kids' behavior. You don't want to be in a place where you wish you could see those videotapes again but can't. You'll want to watch them. Have backups. Of course, you still need to follow security protocols for those data as well. You need to be just as careful with your methods. You think that you'll always remember how you abstracted data on those kids' activities from the videotapes months later, but you won't. You'll forget some tiny detail. Maybe the order of recorded variables will be different. Maybe that will change what you see, and therefore that might change the results of the study. Every significant detail must be recorded in a way that will make sense to others, in a way that will last, and in a way that won't be lost. Best practices call for a formal documentation of the methods. Create a study manual that details how to do every single step. Have someone who isn't involved in the study read it and describe the methods back to you. If they can't tell what you plan to do ahead of time, you didn't document it clearly enough. One final warning. People love technology because it often makes things easier. This is especially true when it comes to automating the collection and recording of data. But automation comes with a price. It's just as easy to record bad data as good data. Maybe a machine can measure children's activity, but if you don't check it periodically, it could record faulty data for a long time without you realizing it. Maybe your lab has some fancy pants technology which can now measure a protein's activity without your having to perform laborious experiments. Maybe a new scanner can tell you something about a mouse's blood pressure without your having to handle them. All of these things sound fantastic until you realize that they might have been off for some time. You need to calibrate such things regularly. Go watch that episode again. And all of this pales next to the possibility that your computerized database has been recording gibberish for weeks without your knowing it. Sure, that gibberish is backed up in multiple locations, and it's perfectly safe, but it's also totally useless. Check everything. Check it again. This training module is part of a series funded by the National Institutes of Health.